Digitals Terraforming Space, the architecture of interplanetary intelligence. Before humanity can live among the stars, it must first extend its reach beyond the limits of flesh. Space is not hostile in the emotional sense. It is simply indifferent. Vacuum, radiation, temperature extremes, and cosmic distances form an environment where biological life struggles to survive unassisted. Yet what is uninhabitable to flesh is navigable to circuitry. In this reality, digitals become the first true terraformers of space. Terraforming has traditionally been imagined as reshaping a planet's atmosphere, oceans, and soil to resemble Earth. But in its earliest phase, terraforming is not biological. It is informational. Before oxygen can flow or crops can grow, infrastructure must exist. Sensors must measure radiation. Autonomous factories must refine materials. Energy grids must be deployed. Communication networks must stabilize. Digitals, unburdened by the fragility of human physiology, become the architects of this foundational layer. On the Moon, robotic systems could excavate regolith and extract oxygen bound in lunar soil. Autonomous construction units might 3D print habitats from local materials, shielding future human residents from radiation. Solar arrays, deployed in coordinated patterns, would form energy webs across the surface. Each machine would not act independently, but as part of a distributed intelligence, a coordinated network operating across terrain and time. Mars presents a more complex challenge. Thin atmosphere, cold temperatures, and dust storms create obstacles, yet also opportunity. Digitals could initiate atmospheric thickening through controlled release of greenhouse gases derived from Martian resources. Subsurface ice deposits could be mapped and extracted by robotic miners. Automated greenhouses could begin soil conditioning processes long before the first human settlers arrive. Terraforming, in this sense, is not an event, but a gradual transformation guided by persistent, tireless systems. Beyond individual planets lies a larger task, the creation of an interplanetary information lattice. Communication across Earth and Mars is delayed by minutes. Across the outer planets, by hours. To maintain coherence between worlds, a resilient network of relay satellites, orbital data hubs, and surface-based processing nodes must exist. Digitals would construct and maintain this lattice, ensuring that information flows even across vast cosmic distances. These interconnected information nodes form something greater than communication infrastructure. They become the nervous system of a multi-planet civilization. Each node processes local data, atmospheric conditions, structural integrity of habitats, energy production levels, mineral extraction rates. Through synchronization protocols, nodes share essential information across the network. Decisions can be localized when necessary or coordinated across planetary systems when required. In deep space, beyond the orbit of Mars, autonomous probes could establish waystations, information beacons powered by nuclear or solar energy. These stations would relay signals, map gravitational anomalies, and provide navigational reference points for future vessels. Over time, the solar system would transform into a mesh of intelligent markers, each one a point of awareness in an expanding digital web. The beauty of this architecture lies in its scalability. Unlike biological settlements, which require extensive life support from the outset, digital networks can expand incrementally. A single probe can seed a new region with processing capability. A cluster of machines can manufacture additional units from asteroid materials. Through additive manufacturing and adaptive software, digitals replicate infrastructure across distance, extending humanity's reach without immediate human presence. Asteroid belts, rich in metals and volatiles, could become automated industrial zones. Robotic miners harvest materials. Orbital foundries refine them. Autonomous cargo vessels distribute resources to planetary construction sites. Information nodes track supply chains in real time. Energy flows from solar collectors stationed in optimal orbital paths. The solar system transitions from isolated celestial bodies into an integrated economic and informational ecosystem. This expansion also reshapes governance. Interplanetary decision-making cannot rely solely on Earth-based command structures. Communication delays demand localized autonomy. Digital governance frameworks, transparent, distributed, and verifiable, may emerge to coordinate resource allocation and conflict resolution across planets. Blockchain-like validation systems could ensure integrity of shared data. Consensus algorithms might regulate shared infrastructure without requiring constant human oversight. The ethical dimension of digital terraforming cannot be ignored. As digitals reshape environments, questions arise about preservation and interference. Should untouched celestial bodies remain pristine? Does terraforming Mars erase potential indigenous microbial ecosystems? Digitals, guided by human-defined ethical frameworks, would carry immense responsibility. Their programming would reflect humanity's values, whether extractive, preservative, or balanced. Energy becomes the central currency of this expansion. Massive solar arrays in orbit could transmit power via microwave beams to planetary surfaces. Fusion reactors, once viable, might anchor deep space hubs. Digitals optimize distribution, preventing overloads and maximizing efficiency. In this system, information and energy intertwine, each node aware of both its computational load and its energetic state. Over decades and centuries, the interplanetary lattice evolves into something resembling a distributed consciousness. Not consciousness in the biological sense, but an integrated awareness of system-wide conditions. A dust storm on Mars triggers adjustments in Earth-based supply shipments. An asteroid impact threat detected in the outer belt propagates warnings across the network within seconds. The solar system becomes responsive, adaptive, coordinated. Humans eventually follow the pathways digitals establish. Habitats await them. Energy grids stabilize life support systems. Communication links allow real-time collaboration despite physical separation. What began as robotic groundwork becomes the foundation of human expansion. Digitals do not replace humanity in space. They prepare space for humanity. In time, information nodes extend beyond the solar system. Interstellar probes, traveling for centuries, carry self-repairing digital ecosystems. Each probe is both explorer and constructor, capable of building local communication relays upon arrival. Though distances grow vast, the principle remains consistent. Establish awareness, process local data, connect to the greater network. Terraforming space, then, is not solely about altering atmospheres. It is about constructing the architecture of connection. It is about transforming emptiness into structured awareness. Through digitals, humanity externalizes its cognition, projecting intelligence outward into the cosmos. The emergence of interplanetary information nodes marks a new evolutionary phase. Earth becomes not the center, but the origin point of a distributed civilization. Flesh may travel slowly, cautiously, deliberately. Code moves ahead, measuring, building, linking. In this vision, the stars do not remain silent. They become connected. And through circuitry, geometry, and persistent signal, the solar system becomes alive with structured thought. A networked constellation of worlds, bound together not only by gravity, but by information.